KCC105, weeks number 5 and 6. We are talking about exponential growth, and in this video we're going to compare it to linear growth. Last one we used exponential. We saw it on a spreadsheet. Let's compare. How did we do it last time? I said, here's the years. We're talking about our money. Let's start with 500, and I will look at the bank rate website. We talked about an interest rate 1.45. Quick refresher. How did we get the exponential growth? Equals. Click the box. Click the 500. Multiply. When you do an exponential growth, you always have a multiply. Parentheses. How come parentheses? There's two numbers I need. I need the 1 to represent keep the money from last time, plus, and then I need the interest rate, 1.45%, and then finish the parentheses. There we go. It does the calculation, says, hey, next year you can have $507.25. You can type again, equals, click that box, multiply, parentheses, 1 plus, interest rate, 1.45%, close parentheses, we're on our way. But the quick way to do it using a spreadsheet, click this box, the box in the corner, click that box and pull it down. We've got the pattern here, and we know that we can highlight all that, insert, chart. It doesn't, histogram, I'm not sure about that, but I go up here and I say, no, I want to see a line graph, see it over time. Great, we get an exponential graph. We saw that last video. But now I want to compare it to linear growth. So I'm going to make another column right next to it. Don't put this column over to the side or anything like that. And I'm going to have another set of numbers, and I want to compare them to the exponential growth. One thing, let's start with 500, because if we're going to do a comparison, let's compare apples to apples, so to speak. Same amount of money to start. Okay, now this next box, how am I going to get that? I need a formula, I need something like that. Well, let's go down here. I'm going to type this, linear growth equals. Now, linear growth, we know something changes every year, but this accelerates over time. The numbers get bigger and bigger and bigger. The growth between the numbers gets bigger. But what I'm going to do is I'm going to approximate linear growth by just looking at that first interval. What happened between the first and second years? Well, how much money did I went up? I went up $7.25. And if you don't believe me, go take a pocket calculator and you can subtract those numbers. Yes, you got $7.25. So what I'm going to do here is I'm going to use that interval to approximate linear growth. I'm going to say, wait, $7.25, and I'm going to type every year. You might say, but it's not every year. I agree with you, but we're going to approximate linear growth. So what do I do? That means take that 725, pop back over here, and do what you did last week. The week 4 assignment equals. Click that box, the previous one, plus, linear growth is a plus, exponentials multiply, $7.25. And it says, yeah, right there. Everything matches up so far, but then if you click that box and pull the formula down, you'll see things, okay, they're close, like right here, $5.85, $5.79. All right, you're missing $6. They're close, but they're not equal. And so now I'm able to compare the numbers visually. Let's compare them in a graph. It's a little different than before. Last time we highlighted everything and went up to insert and hit chart. But if you do that, you get lots of things going on. And even if you try to go to line right here, whoa, there's two different things get messy. If you have a comparison, which you're going to have here, this is your strategy. You got to highlight the money and you have to highlight the money numbers, not the year numbers. Just highlight the money numbers. Insert, chart. There we go. Oh, that's bar graph. I still don't want that. Now I want the line graph. There we go. Look what happens. Now I can see the two types of lines. Linear growth is lower. My money, the exponential growth, I could even change that. Exponential growth. There we go. Exponential growth, you see how it's higher than the linear growth. Another word we could use, I'm talking about compounding interest, and this would be the simple interest. The compounding interest is winning out. It takes a little while for it to win out, but it does win out in the end, and you can see that the money numbers. That over these 20 years, you can have $700, whereas if you just had the simple, it'll be the red line is closer to $650. Okay, that's how we're approaching the comparison for the week 5 and 6 assignment. You know how to do the exponential growth from the last video. For the linear growth, quick refresher on this. What do you need to do? Start with the same number. Find out how much it changes in the first year. And honestly, that's a quick observation. Just my eyeball, I can say, oh, it's 725. Whatever it changes by equals this plus that change. And then drag it down. So in other words, you're assuming it changes the same every time. I know it doesn't, but we're assuming it does. Then once you make that assumption, you highlight all the money numbers, not the years. Insert, chart. Hey, we get this. Let's dress it up. Let's make it a line graph. And then this is a graph that we can put in our graphic for week 5 and 6. That's one comparison. You'll see the assignment. I'm asking for 3 comparisons. I think the bank rate is a good one that everybody can do, and I'll show you some ideas for 2 other comparisons in the next video. Very last thing, I'll see if I can do this in about 30 seconds here. It'd be nice to have the years down here. Wouldn't it be nice to say, okay, this is 2018, 2020, 2025, and so on. It'd be nice to see the scale of time. If you go up on this little chart, where the same place where I selected the type of chart, it says x-axis. Well, yeah, if you remember back in high school algebra, x goes this way, y goes up and down, x goes sideways. So add x. Yes, I do. Click the tic-tac-toe grid. It says what data? The x-axis, I want to be the years. So I highlight all the years, hit OK, and there we go. Nice. This gives me a way to say over time, so by 2040, you got that much difference in the money. So if you can hold out 20 years, your money's going to grow a little bit. Is that a reasonable trade-off? You know, that's a personal question, but you see the point of interest of compounding exponential growth is more time means more money. All right. Those are the basics for making a linear and exponential comparison. Check out the 3rd video, and I'll give you some other examples besides the American Express, besides the bank interest rates to represent exponential and linear growth.